Okay, so filming this ahead of time, again, this is a resource that you can use at home or outside of class. So to start with the distributive property, it says to apply the distributive property to the following expression. So this is interesting because what I see here is that I have a negative sign in front of negative 2x minus 4. So if I think back to what I learned in 6th grade, what I learned is that the negative sign can also mean the opposite. So what I need to do is I'm going to distribute a negative across both of these terms. So if this is a positive 2x, if I have a negative 2x in front of it, a negative sign, excuse me, it's going to become a negative 2x. And now when I have a negative sign and a negative sign, that works together and becomes a positive. So notice that the signs of my end result are opposite of what I started out with. This one was positive, it became negative. This one was negative, it became positive. Okay. So turning the page, here's what we're going to do today. One thing to notice is that exit card got pushed back to Monday because we need to get on the same page as the other IM classes. That's going to be worth 10 points, and you can get error corrections on that if you want. Okay, but that doesn't mean don't study. That just means you can do error corrections. All right, so we're throwing it way back to area, okay, which is something I know you guys know how to do. So remember that the formula for area is area equals length times width. So here what I have is a square or a rectangle with a length of 4 and a width of 3. So if area is equal to length times width, then area is going to be equal to 4 times 3, which is equal to 12. Easy enough. You guys absolutely know how to do that. So here we make it a little more complicated. We have a length of 4, and then we have a width that says parentheses 3 plus 5. Okay, and I know that you could add 3 plus 5 and get 8, but just bear with me for a second. Let's try to keep this format the same because it's going to benefit us when down here we have parentheses, not when we have parentheses, when we have a variable. So again, my area is equal to length times width, which is equal to 4 times 3 plus 5. Now this format should look familiar. What format do I have there? Oh, I have the distributive property, which is equal to 4 times 3 plus 4 times 5, which is equal to 12 plus 20. And same thing, it is equal to 32, but what we have to realize is that it can be broken apart into all of these different pieces, okay? The length and the width can be 4 and 3 plus 5, 4 times 3 plus 5, it can be this, 4 times 3 plus 4 times 5, it can be this, 12 plus 20, or it can be 32. These are all equivalent forms of the same expression. Okay, but this structure that we use is going to help us here because now we have a variable. So again, we know that area is equal to length times width, and area is equal to 4 times x plus 5. So again, just like up here, it's helpful if we use the distributive property. Now we don't have a number in that place, so we have to use the distributive property to figure it out. So now we have 4 times x plus 4 times 5, which is equal to 4x plus 20. Okay, so what I've done here is I've applied area, my knowledge of area, and the distributive property. So now what I'm going to do is I'm going to talk about factoring. Okay, and remember that a factor is just a number. Is that clear? A number that goes into a larger number evenly. So in my first box, I had the area of 12. So what are the factors of 12? So let's think about this. So my factor pairs are 1 and 12, 2 and 6, 3 and 4. Those are all the numbers that go into 12 evenly. Okay, so now I have my area. Remember that I had the dimensions, the sides of 4 and 3 plus 5, which gave me an area of 12 plus 20. And how can I factor 12 plus 20? Well, when I factor, I want to end up essentially with this format. So what I have to do is I have to find common factors of 12 and 20. So I have my common factors of 12. Now what I have to do is think about my common factors of 20. 1 and 20, 2 and 10, 4 and 5. Now, if we use 4 as a factor, we're going to end up with exactly the same form that we have here. So let's use another common factor. Let's use 2. That's the only other one we have. Now remember, factors go evenly into a number. They're being multiplied into a number. So if I divide 12 by 2, what I end up with is 6. If I divide 20 by 2, what I end up with is 10. And again, if I multiply this back through, I'll end up with 12 plus 20. It's exactly the same as here. It's exactly the same as this. These are all equivalent expressions. I'm just breaking them apart in different ways. So now what I'm going to do is I'm going to look at this, which has a variable in it. So now I have 4x plus 20, and I want to factor that, 4x plus 20. So I'm going to use exactly the same process. I just have an x in there. So I need to think about what are my common factors of 20 and 4. So I have 1, 2, and 4. On this side, I have 1 and 20, 2 and 10, 4 and 5. So we could use 4, or we could use 2. If I use 2, 4x divided by 2 is 2x plus 10. And if I multiply that back through, I'll get 4x plus 20. If I factor out 4, I'll end up with my original expression, 4x plus 5. Okay, so it's obviously a lot easier to see these connections when you have the factored form already given to you. So let's look at an example where we only have the end result. We don't have both forms given to us. So it says, factor the expression 15 plus 45. Notice that it doesn't say solve, okay? There's no equal sign. It doesn't want me to say that 15 plus 45 is 60. We know that. It wants me to factor the expression. So the factors of 15 and 45, right away you should see 15 and 45 both end with 5. That means that 5 is a common factor. 1, 3, 5, and 15. 45 has a lot of factors. 1 and 45, 3 and 15. Let's see. 5 and 9. So I could use 3 or 5 or 15. Let's use 5. So if I bring my 5 to the outside, and then I have 15 divided by 5 is 3, 45 divided by 5 is 9. And if I multiply that back through, I should end up with 15 plus 45, which I do. Okay. Now my expression is a little bit more complicated. I have 8x plus 12 plus 24x. It's a lot more complicated, actually. So what I have to do is I have to think about my factors of 8, 12, and 24. So 1 and 8, 2 and 4, 1, 12, 2, 6, 3, 4. 24 has a lot of factors too. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Okay, so I could use 2 or I could use 4. I can't use 8. Those are my common factors. So let's do 4. So if I factor out 4, what I'm going to be left with on the inside is 2x plus 12. Oh, no, not plus 12. I factored out 4. Plus 3 plus 6x. So that's one way of doing it. I can also factor out 2. If I factor out 2, then when I divide, what I'm left with is 4x plus 6 plus 12x. And you can combine the like terms here too. So you could end up with 2, and that makes 16x plus 6. You could absolutely do that. These are all equivalent expressions. It just depends what it is that you're trying to do. You can manipulate these expressions in any way that's going to be helpful for you to solve the problem. So that is it. And I know that was a lot, so you might want to watch it more than once and make sure that you're taking good notes in class.